Hello and welcome to this calculus video. Today we'll be looking at limits.
Math 112.
Firstly, what is a limit? Well, a limit is an answer to a question like, what would we predict the value of a function f to be at a point if we know the value of f at nearby points? Let's look at a few examples. In the first example, the graph of the function has a hole that we would like to fill in. The y value of that hole would be the limit of this function at x equals 2. In this case, that value is 4. In the second example, we have a piecewise function. However, there is still a hole that we can fill in, and the y value of that point would be the limit of the second function at x equals 2. In this case, that value is also 4. In the third example, there is no obvious choice of point to fill in. If we look to the left-hand side of x equals 2, we get y equals 4. And if we look to the right-hand side, we get y equals 2. This means that we can't predict the value of the function by looking nearby, because we don't have a single answer. In this example, we would say that there is no limit at x equals 2, or the limit does not exist. Now we are going to introduce some notation. This expression is read, the limit as x approaches a of f of x is L. What this means is that the value of f of x gets arbitrarily close to L as x gets close to a. If we say the limit exists, then we mean there is some value L that f of x is approaching. So when we say the limit does not exist, we mean there is no such value L. Let's look at an example. Consider the function f of x equals x minus 1 divided by x squared minus 1. Desmos gives us this graph for the function. Let's think about what happens when we plug in x equals 1. Well, when we plug in x equals 1 to the denominator, it will evaluate to 0. We'd then be dividing by 0, which is undefined. That means our function is undefined at x equals 1. Now let's investigate the limit as x approaches 1 of f of x by plugging in nearby values. It might be good to use a calculator here. Firstly, let's do x equals 1.1. Now let's do x equals 0.9, x equals 1.01, and x equals 0.99. From the values we get, we might guess that the limit is a half. Let's look back at one of our previous examples. Here, the limit at x equals 2 does not exist because the part of the graph to the left wants it to be 4, whereas the part of the graph to the right wants it to be 2. These are examples of one-sided limits. We say the left-handed limit, or limit from the left, or limit from below, of the function f at the point x equals a is L, if we can make the value of f close to L by making the value of x close to, but less than a. Note that in the subscript, the a now has a little minus sign attached to indicate we are taking a left-handed limit. Similarly, we can take a right-handed limit, or limit from the right, also called a limit from above, and only consider x values above a. Here, we have a little plus sign attached to the a. We have one more kind of limit to talk about today. These are limits where the function has a vertical asymptote. In these cases, the value of the function is becoming extremely large, at least in absolute value, as x approaches the limiting point. We say the limit as x approaches a of fx is infinity if the values of f can be made arbitrarily large and positive by making x be close to a. There is a similar definition for f of x approaching negative infinity, but we have to make f of x arbitrarily large and negative. There are also definitions for the one-sided limits of functions being infinity or negative infinity. To wrap up, in this video we talked about the definition of the limit and introduced notation to talk about limits. We also discussed one-sided limits and limits equaling infinity.
Math 112.